All right, we're going to be talking transformations, and you may not know what that is, and that's okay because that's exactly what we're going to cover. Um, with transformations, what we do is we take some sort of figure and we move it from one position to another. Another word for move is map. I believe that comes up in one of your homework problems. That what would map this thing to the other thing? And map is just another word for move when we talk about transformations. So we're going to take some shape and we're going to move it from one image to another. And that could just be something as simple as a triangle. We're not going to overdo it with complex things. And what we do is we start with, something that is a pre-image, and then we're going to move it somehow using one of the three transformations that we're going to talk about. And then after it gets moved to wherever it goes, however we move it, then we have something that's called the image. So we start with a pre-image, we move it, and we end up with an image. Now, how are we going to move it? Perfectly reasonable question. And we have three different techniques we can use to move or map an image from one position to another. The first of those are called translations. And these transformations have formal words, and then they also have informal words that go with them. The formal words are the ones that we are going to use. If you were doing these with kids in an elementary school setting, you'd probably lean on the informal words, at least to start with. But a translation is like a slide. We're just going to slide it from one place to another. The second transformation that we'll talk about are reflections. And that's going to be like if you were to look in a mirror and you get a reflection, and you could call those flips if you were being less formal. And then finally, we're going to look at rotations, which we're going to rotate, which is exactly what your mind would go to for a rotation, and that could be called a turn. So more formally, the transformations we're going to look at are translations, reflections, and rotations. Informally, we might call those slides, flips, and turns. As we go through these, you make sure to let me know whatever questions you might have. The first transformation we're going to look at are called translations. Remember, these are our slides. We are just going to have some shape and we are going to slide it from one place to another. Translations will have a distance and a direction. How far are we going to move it? The distance. And where are we going to move it to? The direction. And often that distance and direction are given to us by a vector. So we've got this picture, we've got this triangle EFG here that we are going to move. And we're going to move triangle EFG. And well, how are we going to move it? I see this as translation. We're going to do what this vector tells us to do. That's how we're going to move it. And if we look from the start point to the end point of that vector, the end point is where the arrow is, we can see that this goes 1, 2, 3, 4 spaces to the right and 1 space up. So we need to go 4 spaces to the right and 1 space up. And that's how we're going to move our triangle that's in this picture. We're going to go 4 spaces to the right and 1 space up. And you might think, well, how am I supposed to do that? Like, I guess I can imagine picking it up and moving it. What we're going to do is we're just going to move these 3 vertices. If we move point F 4 spaces to the right, 1, 2, 3, 4, and up 1, that's where F is going to get moved to. 4 spaces to the right and up 1. The original triangle we have, triangle EFG, that's our pre-image. And after we move it, we're not going to call the new vertex F anymore. That would be confusing. Instead, what we're going to do is we're going to call it F with an apostrophe, that is F prime. And that's going to be a part of our image, F prime. We're going to do the exact same thing with vertex E and with vertex G. So vertex E, we're going to move 4 spaces to the right. 1, 2, 3, 4, and up 1. I kind of left one behind there, and up 1. And that's where E prime is going to go. I'll put that on in just a minute. I want to go ahead and do G first. And then G is going to go 4 spaces to the right and up 1. And that's where G prime is going to end up. And so now I can redraw my triangle with E prime, F prime, and G prime. And so I have E prime, F prime, and G prime, and that is the image, which is the result of this translation that I've done, which was to slide that triangle over. You can kind of see that it slid just the way that this vector told it to, slide up and to the right, and that's what we did. My drawing of the triangle is not perfect, but you can see how we slid it over there. Anytime you're asked to do a translation, your drawing doesn't have to be perfect either. Are there any questions about this before I try a translation question with you, give you a chance to answer a question about a translation? All right. So we have that same triangle, EFG. Now we have a translation vector that looks like this. My question to you is, find the location of E prime after the given translation is performed. So if we were going to do that translation, where would E prime end up? I'm going to set up a poll for this and let you try it. One thing I do want to say, I don't know if we've talked about the coordinate system. And so just sort of as a reminder, the value of X goes first. That's the horizontal axis. And the value of Y goes second. That's the vertical axis. So for example, if we look at point E, where it starts here, that would be -4, 3. It's -4 in the horizontal direction. That's the X that goes first. And then it's up 3 spaces in the Y direction. So -4, 3 would be the point or the location of point E when this starts out. Point G would be at the point 1, 1, because it's 1 in the horizontal direction and 1 in the vertical direction. And what we're after here is, where would E go? Where would E go if we did the translation that we were given? I'll give you another 30 seconds on this, and then we'll talk about it. All right, let's see what we've got here. Okay, we're spread around the whole thing. All right, that makes this very interesting. We do have some agreement, but we've got all the choices. So let's be patient and careful as we go through this one. The first thing I want to do, and I'll remember to point this out going forward, is the vertex G here is 1 in the x direction, 1 in the y direction. So the coordinates of point G, just where it sits, would be 1, 1, because it's 1 in the positive direction of x, 1 in the positive direction of y. And you can see the x and y labels on these axes. X goes first, y goes second, just as a reminder. We've done the distance formula, so we've seen a little of this, but not a lot, just as far as identifying points on the coordinate plane. Point E back here, it's -4 in the x direction, +3 in the y direction. So the coordinates of point E would be -4, 3. That's where point E would be located. And so that's how we're going to identify points. Now, what we want to do is go down here and take a look at this translation and figure out where point E is going to move to become E prime. So let's see, that's down 2 and over 1, 2, 3. So down 2 over 3. That's how we need to move. To the right 3, I guess I should say. Down 2 and to the right 3. So if I want to figure out where E prime is going to be, I need to go from here. I need to go down 2 and to the right 3. And it's going to end up right there. That's where E prime is going to be located, which is the E prime is going to be at the point, kind of wrote in my way there, didn't I? How about we'll put that E prime down here so we can scribble better. So we have E prime down there, and that's -1 in the x direction, +1 in the y direction. So the coordinates of E prime will be -1, 1. And that's where E prime is going to be located. We could move F and G if we wanted to move the whole triangle and draw that in, but all we were asked for is the location of E prime, and that's going to be at the point -1, 1. That was the most common answer, which is great. But if you have any questions about how we found that, please don't hesitate to let me know. Um, Let me make sure I understand that question, Genesis. Is it about using this arrow that we've been given to figure out how to move? Is that the question? Okay. If we look at that arrow, we can see that it has a point over here. That's going to be the end point of our ray, if you want to think of it that way. It's a vector, but because it's given us distance and direction. If we look at that, it starts here and it ends here. And so to get there, we can see that it's down 2 and to the right 3. You could count it the other way if you wanted to. You could say it went to the right 3 and down 2. Basically, what would you do moving horizontally and vertically to get from here to here? And you're going to have to go to the right 3 and down 2. And that's what this vector tells us. And whatever this vector over here tells us, that's what we're going to do with every point in our triangle when we do the translation to find out where E prime, and we could find F prime and G prime also. All right, good, good, very good. If you'd like to find F prime and G prime so that we could redraw the triangle, we can absolutely do that if you want. But if we're good, that's really all there is to translations, is just we are going to slide it. And how are we going to slide it? However the vector tells us to. All right, our second transformation are reflections. Reflections are like a mirror image, and whenever we do a reflection, there's going to be a line of reflection. That's what we are going to reflect the image across. So we're going to be given some image, and we're going to reflect it across the line of reflection. One thing you can imagine here is, if you were able to take ink and really, roll that ink really good right here, and then fold your paper along the line of reflection, and then open up your paper again, what is it that you're left with? That would be how we're sort of performing this reflection. Um, in our course, we're going to be concerned with horizontal and vertical primarily. We might see a diagonal reflection occasionally, but our primary focus is going to be on horizontal and vertical reflections like we see on this page. So if I'm going to reflect this L across this line of reflection, what am I going to end up with? You know, that's sort of our question here. What is it we're going to end up with? And be a little bit careful. Some of you that are very visual, some of you that might be a little more artistic, have no problem seeing what's going to happen here. Be careful. We don't want to do that because that's not a mirror image. That's not what we would get if we folded our paper. Instead, what we're going to end up with is something like that. Now, my drawing there is, it's the right shape of L, but you know, that's not a very good, because if you look at it, this L is a lot closer to the line than this L. So that's not really where it would go if I were to fold my paper. You know, if I folded my paper, I'm going to be over here somewhere. That's more where the L should go. Technically, formally, if we were doing this in a very formal manner, what we would find is if we make a vertex here at the top of the L and we connect those, what we find is for a reflection, the distance from the line of reflection is the same on both sides, and the line connecting those 2 points is perpendicular to the line of reflection. So if we were trying to be extremely formal about drawing in our reflected L, that's how we would go about it. For us, we're just kind of making a sketch here, so it's okay if it's not perfect. But technically, it's when we do a reflection, we are going perpendicular to the line of reflection, the same distance. And that happens at each point. Perpendicular to the line of reflection, the same distance. And that's how we end up with our reflection. As far as a sketch goes, this L is just fine. This backwards L is just fine. All right, now we've got to do this vertical reflection over here because we can see our line of reflection is this line right here. So we're going to go vertically down to the bottom. It's a horizontal line of reflection, so we're going to go down here. All right, let's see. Be careful here. I don't want to do this, right? You can see how that's not reflected. If I were to get this one all covered in ink and fold it, that's not what the reflection is going to look like. In fact, looking at this L would have just been slid down there. That would have been a translation. We're not doing a translation, we're doing a reflection. So I want a mirror image of what I have. Again, those of you who are really good visually, really good artistically, will have no problem with this at all. Those of you who may struggle a bit might want to check your answer by kind of going, all right, if I look at this point, I need to go perpendicular to the line of reflection, same distance away. Perpendicular to the line of reflection, same distance away. Okay, I feel good about that red L that I have down there as a reflection. Are there any questions about what we did there to reflect those L's before we try a couple reflection questions? All right, here we go. Find the location of B prime when the triangle is reflected across the y-axis. So what we've been given now is we've been given this triangle ABC, and we're going to reflect it across the y-axis. First, we have to make sure we identify the y-axis correctly. That's the vertical axis here. So that's going to be our line of reflection, is the y-axis. We're going to reflect across the y-axis. And my question to you is, if we were to reflect that triangle across the y-axis, where is B prime going to end up? When we find our image, where will B prime be? I'm going to set up a poll for this one, and we'll see how we do. If you want to reflect the whole triangle, you can, but you don't have to. This question only asked about B prime. So really, the only thing we have to consider a reflection of is point B. We'll go another 15 seconds on this one and then talk through it together. All right, let's see. Okay, very strong agreement on this one. Outstanding. Very good. Very good. So either really comfortable with reflections, a little more comfortable with the X and Y axis and the coordinate plane, whatever it is, that was outstanding. Let's take a look. So if we're going to reflect this triangle across the Y axis, so this is our line of reflection. Some of you can probably visually just kind of look at this and go, well, yeah, the new one's going to go like that. Okay, great. If that's you, that's fantastic. Others might say, wait, I need to go perpendicular to the line of reflection, same distance away. I don't know what the triangle is going to look like, but there's where B prime is going to go. We could do the rest of the triangle if we wanted to, but we didn't have to. We were just asked for B prime, so we've got it. And that's going to be at the point. Let's see. That's one in the X direction, one in the Y direction. So B prime here is at the point 1, 1. If we wanted to reflect the others just for fun, we could do that. We could take C and go directly perpendicular to the line of reflection, same distance. That's where C prime is going to be. And then A is over here, and that's 1, 2, 3, 4 to the line of reflection. So 1, 2, 3, 4 over here is where A prime is going to go. And that's where my new triangle would be. Triangle A prime, B prime, C prime would be over there. That would be a reflection across the Y axis. Let me know if you have questions on that before I have you try one more. Awesome. Find the location of C prime when the triangle is reflected across the X axis. So this time we're reflecting across the X axis, and we want to know where is C prime going to end up. We'll go another 15 seconds on this one and then talk about it. Take a look. Okay, real strong agreement again. That's great. Very good. Let's go back and take a look. And if you have any questions, you let me know. One thing here is to make sure we read that question carefully, and it says, find the location of C prime when the triangle is reflected across the x-axis. So now the x-axis, or this line, is going to be our line of reflection. So we're going to reflect that direction. And when we do that, I'm just going to go ahead and do the whole triangle. For B, we go straight at the perpendicular to the line of reflection, same distance. This is where B prime is going to end up. C prime is going to go 1, 2, 3, 4. So 1, 2, 3, 4, all the way down here is where C prime is going to be. And we'll answer our question in just a minute. And A prime, perpendicular to the line of reflection, same distance. There's where A prime goes. So this is our reflected triangle down there. And those blue might not make it easy to see because I used the blue. There we go. There's our reflected triangle. Question said, what is the location of C prime? And that's right here. And that's, let's see, -1 and 1, 2, 3, 4. So C prime is at -1, -4. Let me know if you have any questions about how we did that reflection or how we identified the location of C prime. The key there, I think the only reason anybody missed that one is make sure you're reflecting across the x-axis if that's what you're told to do. Some relatively interesting reflection problems can be like this one. Where would the line of reflection be? So now we're not given a shape and told to reflect it across a line. Instead, we're given an image and a pre-image, and we're asked, where would the line of reflection be? It doesn't really matter which one's the image and which one's the pre-image. I kind of look at this one and think that the solid one is the pre-image and the dotted one is the image after the reflection, but it really doesn't matter. So let's see here. This first one is the line of reflection, and I'm not going to do a poll for this. I'm just going to ask you, is the line of reflection horizontal, vertical, or diagonal? So for this first one over here on the left, is our line of reflection horizontal, vertical, or diagonal? All right, Lorraine, Natalie, perfect. Yeah, if we look at that one, there's a couple of ways you can do this. Some of you who are very visual go, well, if you wanted to reflect this, you'd put the line right there. Great, perfect. If that doesn't happen for you right away, because seeing these things isn't that automatic for you, what you can do is the reverse of what we did when we were actually reflecting the pre-image across the line. You can say, well, this point got reflected from here. So if I go perpendicular, same distance away, and same thing happened here, perpendicular, same distance away, so that puts my line of reflection, it's got to be perpendicular and the same distance from those points. And then I can draw my line of reflection. So the purple one would be our line of reflection, and it's a horizontal line. Okay, the second one that's in the middle. Would my line of reflection be vertical, horizontal, or diagonal? Perfect, Natalie, Nicole, yes, vertical. Emily, I'm guessing you're right behind them on vertical, and please type it. The more people that say it, the more people I know are right there with me. So yeah, and you could visually just kind of drop it in there, or you might say, well, these 2 points would be reflected, and these 2 points would be reflected. And okay, so I need to make sure that my line of reflection here is halfway between those and perpendicular. That's not great. How about, that's not terrible. Okay, and so there, my line of reflection, what I would have reflected across, where I would have folded my paper to get one of these to land on the other, would be this vertical line. And then finally, you can see on the right, that one's going to be diagonal. Might be a little harder to see. Some of you probably look at that and go, well, sure, the line's right here. Obviously, if that's you, that's fantastic. If it's not, we can use that same philosophy we've been using, where we say, all right, well, this point got reflected to here. So if I connect those, and This point got reflected to here, so if I connect those, oh, the line of reflection is going to be perpendicular to those lines and right in the middle, and so that's where my line of reflection goes. And so here I have a diagonal line of reflection. We won't do a ton with diagonal lines of reflection, but I do want you to be aware of them. We've talked translations, we've talked reflections. Before we get into rotations, does anybody have any questions they want to ask about anything we've done so far? Okay, very good. Rotations. Rotations are going to be turns. We're going to rotate. And rotations always have a center of rotation and then an angle that tells us how far to go. So at the beginning, we had those vectors that told us what direction to go when we did a translation. With a rotation, we need to know how far to go. That's going to be the angle. And what are we rotating around? What is it that stays put? Occasionally, you're going to see some problems that where the center of rotation is not on the figure, but our focus, the majority of the problems we work on in our class are going to be on shapes with the center of rotation is actually on the figure. It's one of the vertices. The center of rotation is going to be one of the vertices, and we're going to rotate around that. Sometimes, and you'll see it today before we finish, the center of rotation is not on the figure. But the problems we're going to be primarily concerned with, the center of rotation will be one of the vertices of the figure. Here's an example. Determine the rotation image of triangle ABC if it is rotated 90 degrees counterclockwise about point C. Okay, there's a lot of language in there. Rotations are a little more complex than translations and reflections. So let's make sure we understand this language. Determine the rotation image is sort of a fancy way of saying, rotate this thing. What thing? Triangle ABC. Okay, I'm going to rotate triangle ABC. And how am I going to rotate it? I'm going to rotate it 90 degrees. Okay, well, 90 degrees is fine, but am I going this way or am I going this way? I don't know yet. All right, that's where this counterclockwise comes in. Counterclockwise tells us we're going opposite the way that a clock would go. So we're going this direction, and we know we're going 90 degrees. Okay, that's all well and good. I know I'm 90 degrees, and I know I'm counterclockwise, and about point C. This is what gives me my center of rotation. I'm rotating about point C, which means point C is not going to move. Point C is fixed. So point C here is not going to move when I rotate this triangle. Imagine sort of having this triangle as like a piece of paper cut out on a desk, and you put your finger where the point C is, and the rest of it you can sort of spin around and rotate. And that's what's happening here. Is point C is fixed. That's our center of rotation. It can't move, but the rest of the triangle is going to move. And how it's going to move is 90 degrees counterclockwise. You're thinking, do I need to get a protractor? You don't. And the reason you don't is because 90 degrees is a really nice, convenient measurement. What that means is a vertical line, like line segment CA here, is going to become horizontal. When we go 90 degrees, something that's vertical is going to become horizontal. And so if I go 90 degrees counterclockwise, so that's this direction, 90 degrees, what's going to happen then is this vertical line right here, CA, is going to go from being a horizontal line, or excuse me, go from being a vertical line to a horizontal line. And A prime is going to be over there. Okay, well, what about the rest of it? Okay, I'm with you. So this line here, AB, line segment, I should be more formal. This line segment down here, AB, used to be horizontal. When I rotate 90 degrees, it's now going to be vertical. And so I want to draw about the same length if I can. And so B prime is going to wind up over here. And okay, well, your vertical line became horizontal. I can see that, right? The vertical line became horizontal and the horizontal line became vertical. Well, what the heck are you going to do with that diagonal line? Really? I'm just going to play connect the dots at this point. I have everything I need to finish off my triangle, so I'm just going to finish it. So moving the horizontal line, moving the vertical line, that gave me all I needed to finish off drawing this triangle. And I want you to see what's happened here. I had triangle ABC. Imagine it as a piece of paper on the table cut out in the shape of that triangle. And I put my finger down right here on point C to hold that in place because that's my center of rotation. And then I took the rest of the triangle and I rotated it 90 degrees counterclockwise and ended up with triangle A prime, B prime, C. It's still point C because it didn't move. Are there questions about what we did here to end up with the triangle after the rotation was done? Outstanding. Rotations can be a little bit challenging, but if we're good, we're good. All right. There's not really a way for me to set up a poll for this one, but I do want you to just try it. I want you to determine the rotation image of quadrilateral ABCD if it is rotated 90 degrees clockwise about point A. There's a lot of language in there that I want to make sure you're familiar with and comfortable with. We're rotating that quadrilateral ABCD. Kind of looks like a square. I wasn't told that it was a square, so I'll go with quadrilateral. We're rotating 90 degrees clockwise, so the same direction a clock goes, about point A. And that tells us something. Take a minute, maybe two, to perform this rotation, and then we'll talk about it together in a minute or two. If you're still working on it, that's okay. I'm going to go ahead and start through the process of rotating this quadrilateral 90 degrees counterclockwise. So 90 degrees, or excuse me, clockwise. So we're going to go 90 degrees that direction. Okay, around about point A. That means point A is going to be my center of rotation. It's going to be fixed. It's not going to move. So I can imagine having a square cut out of paper. I put my finger down on point A because it's not going to move, and I want to rotate this thing 90 degrees clockwise about point A. You don't have to start here, but it kind of feels like whatever's going to go first, that's what I'm going to move, and I'm going this direction. So I'm going to do line segment AD here first. I'm going to take line segment AD that right now, line segment AD is vertical. So I'm going to rotate that line segment 90 degrees clockwise, and it's going to end up over here, and that's where D prime is going to be. All right, and then see D connects to C down here, that line segment. So I'm going to move that one 90 degrees clockwise. D is going to go this way down here to point C, and that's where C prime will be. That's where C will be after the rotation is over. And then, well, you could do it either way. You could think A connects to B, and it's horizontal now, so it's going to become vertical. You could think that C connects to B, and it's vertical now, it's going to become horizontal. Either way you want to look at that, when you do it, you're going to have C connecting over here to where B prime is going to be, and then finish off our square. And so we rotated 90 degrees clockwise about point A. Point A didn't move, but B became B prime, C became C prime, and D became D prime. And the orange one is our rotated image of the original. Are there any questions about what we did there to rotate that shape? All right. We just have a little bit more to look at today. We had 3 different transformations we were going to look at: translations, reflections, and rotations. And now we're just going to do some practice where identify the transformation that maps the green pre-image to the purple image. So there's vocabulary in here we want to make sure we're comfortable with. Maps means it moved it. You know, it started out in the one place and it moved to the other. Pre-image. The green one is the pre-image. So that is where we started. And then the purple image, that's where we ended. So we started at the green pre-image and we mapped it and ended up with the purple image. And I want you to just think about, I could do a poll for these, but I don't know that it's really necessary. I think we can just sort of take some time and you can decide on A, B, and C, and then I'll talk through them. And then if you got something different for me, or if you don't see how it's the answer that it is, we can absolutely talk about that. You can ask whatever you want to ask rather than doing a poll for everyone. So we're starting with the green pre-image and we're ending up with the purple image. I'll give you some time to go ahead and do all 3 of these, A, B, and C, and then we'll go and talk through all 3 of them one after the other. What is it that gets you from one to the other? What move would you do? Which transformation would you use? Some of you will be able to do these really quickly. Those of you that are really good visually, maybe good at art, might see these immediately and just go boom, 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 done. Others, it might take a little more thought, and that's okay. There's no pressure. I don't want to go too fast for you. Visualizing things is something that isn't easy for everybody. It's not always easy for me, for sure. So I sympathize if you don't see it right away. Some of you will. Some of you may have to really think it through, and that's okay. If you want a little more time, let me know. Otherwise, I'm going to start talking through here these with letter A. With letter A, my first thought is, well, I don't know. If I just go from the green one and slide it down, doesn't that work? Couldn't this be a translation? Well, a translation of A would end up not in that shape. If I translated A, I would end up with this shape, and that's not what I get. So it's not a translation. If I rotate, sort of kind of imagine that getting rotated around, this one would be on the top right, so that's no good. Process of elimination. If I reflect it across this line, that I would end up with the purple one, so this one is a reflection. If you don't see that being a reflection, you let me know and we'll talk about it in more detail. The second one, I think the second one's kind of easy to see, but maybe not. Your first thought might be, well, what if I do a reflection here? But if you do a reflection here, if you kind of imagine, you know, this being the face, the face would have to be looking at the line of reflection, and over here it's not. So reflection doesn't work. This one is a rotation. I don't know how many degrees. The center of rotation is down here somewhere. Imagine putting our finger right there and rotating our paper, and that's how we would get from this. Oh, I'm sorry. Green one's the pre-image. So we're rotating that direction. Our center of rotation's down here, and we're rotating that direction. Imagine holding your finger down on this spot on the paper and just rotate it to get to there. Like I said, you may see from time to time a spot where the center of rotation, the spot that doesn't move, is not a part of the figure. For most of the problems that we're primarily focused on, the center of rotation will be on the figure. And then finally, part C, well, that one's just a, oh, I didn't write rotation here. This one, we're just sliding it up. That one's just a translation. There's no reflection here. There's no rotation here. It's just a slide. If any of those don't make sense, if you're not seeing, dang it, I did it again, didn't I? We're starting with the green and ending with the purple. So we're going that direction. So I'll get my directions figured out here. We have a few more to practice. I'll get my directions right next time, I promise. But the main thing to notice is that we have 3 different transformations: a reflection, a rotation, and a translation. And this is how they impact a pre-image to turn it into an image. Look at a couple more of these. So try these 3 and see what you come up with. We're starting with the green pre-image and ending with the purple image. I will say that F is a borderline trick question, but it won't be when I tell you. You're going to use 2 transformations in F. While you're working on these, I'm going to get in my head that the green is the pre-image and the purple is the image. So what is it that's going to take the green one to the purple one in D, in E, and in F? If you want more time, let me know. Otherwise, I think I'm going to go ahead and start talking about these. The first one, D. Let's see, I might think reflection, but if I did a reflection, what I would end up with would be that way, so that's no good. And I can't slide it to get it there, but if I were to rotate it, and my center of rotation is going to have to be over here somewhere. Again, not the most important thing for you to think about. I want you to be able to identify that this is a rotation. If we rotate the green one, we turn our paper, we can get it to land on the purple one. E, this one you might see pretty easily as, hey, that just looks like a reflection across a line in here. And then F is kind of tough because we're using 2 here, and there's 2 ways you could do it. You could start by doing a reflection across a horizontal line, and that would put you here. And then do a translation to the right. So you could start with a reflection, and then after that, have a translation. And do it that way. Just as effective just as good, you could have said, well, what if I do a translation first, and then after my translation, then I do my reflection? That works too. So the two that we would use there involve either a reflection first and then a translation, or a translation first and then a reflection afterwards. So we had to use two things to get that accomplished, to move from the green to the purple. Okay, we've talked translation, we've talked reflection, and we've talked rotation. If there are any questions about what we've talked about so far, let me know. I just have one more thing I wanted to say, and that's a homework note. Number 3 asks you to do a translation, and then does this does your image overlap your pre-image? You can ignore the does it overlap part. I just want you to do the translation. It's a way to practice doing a translation, and that's what I want you to get out of number 3. It's not a, don't worry about answering the question there. It's just do the translation.